Welcome, students, to the section on cholinergic receptors. So, acetylcholine, after this, it is released into the synaptic cleft, it acts on the cholinergic receptors. So, what are cholinergic receptors? We have muscarinic receptors and nicotinic receptors. These are the cholinergic receptors. So, why are they called so? So, by acting on the muscarinic receptors, they produce muscarinic action. So, the action produced to the muscarinic receptors is similar to the action produced by the poisonous mushroom alkaloid muscarine. And by acting on the nicotinic receptors, they produce action which is similar to the action produced by the tobacco alkaloid nicotine. Now coming to the subtypes of muscarinic receptors, we have five subtypes: M1, M2, M3, M4, and M5. You need to know the location of each receptor. So muscarinic receptor M1 is present on the CNS neurons, sympathetic postganglionic neurons, and gastric ones. They are usually excitatory in nature. M1 is excitatory. M2 is present on the myocardium, on the heart, smooth muscles, presynaptic sites, and CNS neurons. So on the presynaptic sites, it's usually autoreceptors, and stimulation of these receptors produce inhibition of the acetylcholine release. So M2 receptor is usually inhibitory in nature. Next, you have M3 receptors. M3 receptors are present on the exocrine glands, vessels, and visceral smooth muscles. They are also excitatory in nature. And M4 and M5, they are mainly present on the CNS. So, of the five subtypes of muscarinic receptors, M1, M2, M3 are very important. So, these muscarinic receptors are G protein coupled receptors. So, among the subtypes, M2 and M4 they mainly act through the adenyl cyclase cyclic GMP pathway, whereas M1, M3, and M5 they act through the phospholipase C IP3 DAG pathway. Now coming to the nicotinic receptors. Nicotinic receptors, we have two subtypes. We have nicotinic receptor, that is NN receptor, and NM receptor. Okay. So NN receptor is mainly present on the postganglionic neurons, spinal cord, and certain areas in the brain. So stimulation of NN receptor will produce depolarization of the ganglionic membrane, and NM receptor is mainly present in the neuromuscular junction, the skeletal muscle, neuromuscular end plate. The stimulation of this receptor produces contraction of the skeletal muscles. Nicotine receptor is a ligand-gated ion channel. They contain five subunits, which is usually arranged by the rosette enclosing a ion channel. So here you have the sodium channel enclosing five subunit, and you have alpha, 2 alpha, beta, gamma, and delta subunit. Five subunit enclosing the sodium channel. So on this alpha subunit, we have acetylcholine binding site. So once acetylcholine binds to this alpha subunit, the subunit that rosette opens up, leading to the influx of sodium, which produces depolarization. Here you can see the different subunits, and on the alpha subunit, the acetylcholine binding site, and hence here you can see the pore where when opened, it opens up leading to the influx of sodium. So with that, we come to the end of the cholinergic receptors. Thank you.